Welcome to this mix for the Our Dynamic Universe unit on equations of motion. And this is the second part looking at direction in equation of motion questions. The direction plays a really important consideration in questions on equation of motion. And the direction is set by you, the person answering the question, but usually you choose one direction as positive and one direction as negative because the quantities are vector quantities. When using the equation of motion, it's very important that direction is considered. In the following examples, upwards motion is taken as positive, so downward motion is taken to be negative. Now, this is something that you as the question answerer can pick, but generally it's best to follow the convention. So up is positive, down is negative. Usually right is positive, left is negative. So let's look at this. A helicopter is traveling upwards with a velocity of 25 meters per second. A package is released and it hits the ground 14 seconds later. This motion has two directions and we need to distinguish between those two. So we're going to choose the upwards direction as positive. So we're asked how long it will take the package to reach its maximum height. So on the left hand side here we've written our suvat. We're going to add in the S, and then we're saying our initial velocity, well, the package was in the helicopter and the helicopter was going upwards at 25 meters per second, so that is why we have made this one positive, the initial velocity. The acceleration due to gravity is downwards, so that is why we've made that minus 9.8. And that's really important. If those don't have opposite signs, then you will get a totally different answer to the answer that you need to be getting. So when we're working out the time, we can pick our equation of motion, v equals u plus at, and we can substitute in our numbers. But we've got to be really careful to make sure that we've got minus 9.8, which is why it ends up being 9.8 is equal to 25. 9.8t is equal to 25. So now we have to work out the how high it is before it's been released. So we should also have written v there too. So we've got our suvat down the side. So we've got u as our initial velocity upwards. So that was plus. We've got a is our acceleration downwards. So that is minus. We've got our time, and we've just worked out from the previous part our velocity. So s equals ut plus half at squared to work out how high it's gone up. And we've got 25 times 2.55, that's plus 25. And then we've got half times minus 9.8 times 2.55 squared. So take care with the signs to get our displacement. We're then asked to work out what is the velocity of the package just before it hits the ground. Okay, so we write out our quantities down the side. I would write s there too. And we've got our v equals u plus at. So we've got 25 plus upwards minus 9.8 downwards. And it's falling for 14 seconds now, because remember the parcel was going up for 2.5 seconds and then it was going down for 14 seconds. Okay, the negative in our answer here just indicates that compared to the initial velocity upwards, it's traveling downwards. We might be asked how high above the ground is the helicopter when the package is released, and we've got to work out our displacement here. So our initial velocity is 25. Our time for the whole part is 14. Our acceleration is minus 9.8. So again, the signs are important. Then we can substitute into our equation of motion. And we get 610.4 meters. We get minus that because relative to the helicopter, the ground is 610 meters below it. So you need to be able to know how to lay out the problems, and you need to be able to solve with vertical motion, being careful with the signs for the positive and negative values. So generally up is positive and down is negative. So that usually means that A is minus 9.8 meters per second squared. If you stick with that every time, you'll rarely go wrong.